Good morning, folks. I've been sick, so that's why I haven't been streaming. I'm back to about 90%, so I figured today we're going to try to get some cool stuff done. Um, One fun thing to share, I got my handle. No more bunch of numbers at the end of this, at least on X. So, that's my main platform, so it's nice. Anyways, plan for today. Let's see if we can get back into this. Right, so this thing was making a whole bloody mess is what was going on last time. Yeah, this thing was making a whole bloody mess because I was getting tired and lazy and probably sort of sick. So let's not do that this time. Let's actually frickin' think about this. So, I mean, the key issue here, I think, right, is this has to be a CUDA file, which means you can't just like include this thing directly, right? And then it tried to put this in kernel CU. Did I let it do this? Yeah, no, we're not letting it do that mess. Okay, yeah, this is actually what we want. It's just the launch functions here. So it wasn't that far off. It just started to go off the rails a bit. So let's check myself. And let's see what it does. Okay, yeah, so this has failed to import. Undefined symbol. Yeah, this is relatively annoying, I'd say. Hmm. Oh no, because that also produces challenge. That also produces a pain. Okay, I think then we try to make this header file work. Launch functions templated. Let me just, I think this is just a dumb C++ thing, right? Also, is my chat working? I don't see any messages in it. Let me go check on YouTube. Maybe the YouTube chat's not going through. No, it looks fine. Hey, Pepe. Okay, yeah, there it's working. Right, so I wanted to check, template. Anthropic challenge? No. Like, why can I not just find... It's honestly because Stack Overflow, like, not being updated as much anymore. I swear, that's like the only way to find information through the fucking language models now. Template at define templates. Ah. Okay, it doesn't do anything. Cool. Kernel optimization. Yeah. That's cool. I'm not very good at that at all. I mean, Pepe, this is a brand new thing to me. I'm sure they like it though because it's a very short and verifiable task that people understand to be complex. So it's like one of those things where models are very well suited. recruitment wins, then I'm definitely not filling that crap out. I honestly might switch it to, I think then, like, do I really want to give Google money? I don't like giving Anthropic money for Claude Code because I really just do not like what they're doing. Um, but this is being a useful tool, even though it's designed very dumb. Here's your cubicle. Nah, I think it's more like open offices and orgies. Templated wrappers. A damn wrapping everything, huh? Non-templated wrappers. Yeah, this is like turbo garbage. Uh-huh. Hmm. Why the heck are launch functions like this, man? Launch functions, why are they like this? Can you have a cond on the type? I honestly don't even like that we have these templated at all in the first place. I really do not like templates. No, we're not doing constant. That's awful. Hmm. That's awful. Hang on 1 second. All right. Reset the room. What's the objective today? So we need to. I mean, it's mostly refactoring Pepe. Um, so there. How do I explain this? There are just too many moving parts at the moment, right? We have our CUDA code. We have the launch functions for the kernels. We might want to support float and BF16 for some of these. We have to figure that out. Then because that requires NVCC and the rest of the code's G++ or whatever, there is additional binding code. Then Torch has its own module def type code. And then there's PyBind for the Python bindings. There is a CUDA exclusive test. They're like pretty much anytime I want to change anything, there are 8 different places things need to be changed. And it's driving me nuts and it's very confusing. So the objective, I guess today we want to clean stuff up. And I think as far as new stuff, the main thing I'd like to have today is I'd like to have this in a place where we can have more than one environment working with Puffer. So we can have multiple different test environments. We can start doing performance comparisons. The other thing I'm trying to think about is whether I want to have a if I want to have C++ fallback. I mean, because presumably the CPU has memory bandwidth as well, right? So presumably we actually have faster C++ code as well than original Torch. Okay, see, it's going to put this absolute garbage at the end of it. Yeah, I hate this completely. You see what a mess this is? And the thing that I really don't like about this is basically when you're doing this, you're saying that humans should not be able to edit code by hand. Because nobody can edit this crap by hand. And I do not like that. The fact that this thing even considers this a reasonable solution is disgusting. Like, we can try this to have something working for now, but this is just not. And it'll say, oh yeah, this is just standard, but it's not standard to add, like, unmaintainable crap. And see, it's like really obnoxious because I'm going to do this for now, but I have to remember to take this out because, like, this is unshippable. Here, you'll see exactly what this does. Watch this. Look at this. That's awful, right? This is just like templating brain rot. And what do we have here? Okay, this chunk, this is the only thing that's actually fine. Open code. Isn't open code an IDE? I'm not swapping my IDE. No, it's just a model. Wait, where does it get hosted then? Connect to whatever provider. That's kind of cool. So what? It's their own. I mean, when people say agent, they literally mean we wrote for loops over an LLM. So they just have to open source that chunk of it, and then they use the model for whatever. That's actually kind of cool, because then that would mean that pretty much as soon as you have a decent open source model, you can directly just replace their crap. Well, I'm not going to interrupt my work session to try this right now, but I might set aside some time to try this at some point here. Stop giving Anthropic money. I actually don't know what model I would even use. Holy crap, what is this? Oh, that's fine. It's just replacing the template calls. Yeah, that's fine. I actually, the little line where it says like clauding, vibing, pontificating, I consider that like particularly stupid. Like every part of this is just, meh. It's free for now. So if you keep, but I'm not banging my head against Claude because the problem isn't the model, dude. Right? And this is man, this is the problem with like the heavy LLM users. It's as soon as there's a problem, it's like, oh, you need a smarter model. Like, no, you need to understand what's going on here. So what's going on here, right, is that we have CUDA code in .CUDA files, okay? And we have a couple of those functions that are templated because they need to support float and BF16, and that's what C++ does for that. And it's supposed to make things less redundant, right? But then because you can't easily export templated functions between CUDA code and C++, as far as I can tell. They end up duplicating everything and wrapping the templated functions to be non-templated. So you end up with the templating crap, and you also end up with all the overhead that you would have ended up with anyways if you don't do templating. And because you have it in CUDA and in C++, now you have it in two places, and now your code base is just a steaming pile of shit. Like, that's what's going on here, right? So I don't need a model to think about how to do this better for me. Okay, so this is the gross solution, but this does run. We need to hear this. Tough luck. I mean, exactly, right? Don't replace your thinking with a fucking model. I think, though, for now, I don't want to do... Do I want to figure this thing out right now? The thing that I don't... Okay, the reason I don't want to invest a ton of time in this right now, though, is because I actually don't even know if we need to keep float plus BF16 for this stuff. You know? I actually don't know about that. So we might just be able to delete everything because we only need it in float 32. And actually, I could get this to write a timing test pretty simply as well. Well, the thing is, bfloat 16 is still stored in 32 bits, right? Wait, yeah, bfloat 16 is still stored in 32 bits. Let me just double check. What? Oh, Grok is just wrong here. Huh? Oh, you dumbass. Yeah, it's TF32. Okay, never mind. Never mind. It's TF32. Okay. Yeah. I'm thinking of the wrong type. Cool. So there is actually savings here, right? Because if we launch the kernel with bfloat 16, we cut the memory bandwidth in half. So there are actually savings to being able to launch this with bfloat 16. Cool. So we'll leave this then alone for now. Um, Do folks want to see me fight this for the next hour, or should we look at the environment stuff? I gotta go use the restroom real quick, but then the thing that I was thinking that would be more exciting to start on today before we have to really figure out the kernel D-type situation. So we have these environment, like this environment hard coded in. This is breakout, and I was gonna try to get it working with a few other environments so we can see the speed up for like neural MMO and stuff. I think that'll be cooler. Let me use the restroom real quick. I'll be back in a few, and then I think we'll do this unless people really want to figure out the D-type shenanigans first with me. Okay. We'll do this for a bit then. I think this will be the productive thing anyways. Create environments. Right. So we need to come up with a couple of things here. We're not going to worry about the D types for now. This is all the same. This will just be set from flag. So this has to get passed. Dict set int. Okay, I think what we're going to do is we're going to pass the env args. Yeah, we're going to pass the env args. And actually, we can get out of this one. New session. Somebody asked on YouTube why we're getting less streams these days. Why is the YouTube chat not working then? It's been glitchy lately. Hang on. Let me go pull it up since so I can have it. And you've been getting less streams these days because I was sick. That's why. Oh, yeah, there are a whole bunch of messages. Why the hell is it like this, man? Why are my messages not going through? Man. Joseph being super busy. No, it's not. Anish. Only Twitch seems to be working. Well, I have the chat up on the side now. So I will miss fewer messages. That's annoying. Yeah, if anybody wants to find me an easy to set up alternative to Restream that doesn't do this crap that I can just run. Actually, somebody said to just do Streamlabs. I should do that. For whatever reason, it's very, very difficult for me to force myself to do anything than like the main thing that I have in my mind right now, which is this project. Like literally, I try to force myself to do any form of work that isn't this project, and it's very difficult. Extensions, breakout to C. No, can't take a 5 bind 11 dict. Try that. Hey son, Liberty, how you doing? We're gonna see if we can get multiple environments working today with this, and then also, there's still just a whole bunch of cleanup that needs to be done for this. Whole bunch of cleanup. And I've been sick, so I'm a little bit behind on this. I basically have just been playing RuneScape and doing like a little bit of light admin work. I've just not felt good at all. I got sick at the gym, but I'm back to about 90% now. Okay, so this is getting moved. Got rocked by acute bronchitis. That sucks, dude. Are you better? Okay, good. Because I had about a year ago, right? I had what I thought was a flu, and it ended up being pneumonia, and it nearly killed me. That shit is serious. Wait, what? Yes, this is fine. Conferences. COVID, yeah. It's honestly just not worth it in my mind. Like I enjoy being in Maryland, like just for months at a time, in the middle of nowhere with nobody to get me sick and nobody to bug me, and just being able to like focus on my work and my health and doing stuff that I'm proud of. Is just much better that way. Yeah. Though actually my warehouse is more inland. It's not like right on the water. I don't even really need the waterfront, frankly. I just need like a bunch of space. Do my own thing. Pi dict. No, you don't need this, dude. What are we doing here? What are we doing here? Oh, actually, this is not bad. This is not bad. Dict set float. Well, hang on. Why is it like this again? Why is it like this? Wait, why? Wait. Huh? Why is it like this? Dot float value. Ooh. Uh. Why the This was stupid. No. This was stupid. Right? So wait, where did I do? So I did dict item, size capacity. It can have a void value, an int value, or a float value. Right? Set int. Items. And then that gives you this dictionary. And then what? Because it's going to be dict get. Is there a dict get float? Yeah. Int value. This is bad. Posted hyperball thing. How much knowledge do you think one needs to tackle this? Pretty little. Finn and Sam for sure have enough to do it. Necrotic pneumonia. Jesus. I had mycoplasma pneumonia, which is like apparently that goes around barracks and stuff, so that one's like not entirely unexpected. It's not the same type of pneumonia that old people get because their immune systems are crap. Hmm. is fine for now. It's a little iffy, but not that bad, I'd say. Not that bad. Just the naming. Anthropic. I don't know why people get the impression that like I'm a good kernel dev or something because you see me doing kernels here. You guys know I'm like brand new to this, right? Like I'd written one kernel before this Puffer 4 update. I'm just able to learn this stuff fairly quickly. Don't we still need this? What's this? Okay, just renamed. That's fine. Yeah, that's fine. Session management? Session, what do you mean? I maintain there's absolutely zero skill involved with using this. There is zero skill required for this whatsoever. Like what I'm doing now is 100% dependent on my programming knowledge and 0% dependent on any like bullshit how to use the agent thing. You know? This is essentially me just like describing well-defined transformations to the code base and having this type it for me without like screwing up syntax or doing things that mismatch along the way. Like here, look, this looks like a big edit. All this is doing, you see, is dict set float goes to dict set. It's like just a little bit more than you could do with an IDE's refactor tool. That is a very nice trick though, the double cast trick. The fact that a double contains all the integers. That is a very nice trick to know. So if you need to set a value that can be either an int or a float, you store it upstream as a double because a double can contain all the values that would be int or would be float. Instead of having like a struct that has an int and a float. Coding these days? Not really major. If you actually look at what I'm doing, you'll see that's not what it is. Doesn't stirdup literally allocate memory? It does, right? Yep, memory leak. Good job. Yeah, why does that need to be stir duped? Too slow. No, big companies do nothing. And it depends what you're working on. The only way look, the only reason I'm having to do this right now is because I'm working with CUDA and Torch. If I were working with like just Torch or just CUDA, it would be fine. But the stack here, it's seek environment code through DLLs. We've got CUDA kernels. We've got libtorch C++. We've got Python bindings. Everything is super redundant. So every time I'd say like, refactor this thing to be slightly different, things have to get changed in 10 places. And it's pretty much unavoidable. When you're watching me write environment code, you'll see I use this stuff way less because like I can just type the damn code. That's so weird, man. Perfect. The cast will, this is actually C++, this will just fail if this is fine, yeah. So that's way better, right? +8. So you see, even for like a new 5-line function, because this is actually a new piece of code, you see I'm going back and forth with this through 10 iterations. Um, that's a gross type, so we use auto for gross C++ types. Const char star key. And now I think that this is like a respectable little function, right? So that's the amount of scrutiny I subject it to when I have it write actually new code. And why do I not just write this 5-line function myself, you might ask? Let's see. So this is the PyBind API. I don't know the PyBind API, right? I don't write PyBind manually, and I don't like PyBind actually, and I'm only using it because of libtorch. And then aside from that, we also have, I guess the C++ types aren't super relevant here because it's autoed, but there were also, before in intermediate versions, there was weird C++ typing that I'm also not familiar with because I'm not a C++ dev, right? Bindings. It's really not that complicated of a distinction, though, right? It's like, are you actually actively thinking about what you're doing, or are you outsourcing your thinking? 231N, basic RL, PufferLib, cool problems aren't already solved. Yeah, if you check my guide, between my ML and science guide, my ML programming guide and my RL guide, it will take you through the quickest possible way to do that. So you pretty much, you need the basics of multivariate derivative calculus. That's what you need. So you don't need to be super, like, you don't need to know all of your derivative, like, you don't need to be able to be great at taking a ton of derivatives by hand, but like if you see a derivative, you should have some sense that, yeah, that's about what it should be. You need to not get super surprised when you take a derivative over a matrix and you get like a transpose or you get cross terms. There are a couple weird things that can happen with matrix derivatives, so you need to be familiar with that. But frankly, like, that stuff comes up way less often. What's most important is that you understand the chain rule. Like, that one thing from calculus is what you need, because the entirety of ML frameworks are basically just the chain rule applied to modules, so that you can chain together different operations. Like, you can write different layers, and then the backward pass just does the chain rule to get the derivatives backwards. That's all the main math you need. If you're doing some of the stuff I'm doing lately, yeah, occasionally you get slightly fancier stuff, but really the math is pretty light. What is not light is the programming. You need a very good programming background, and that's where most of the time will be spent. Which is why I suggest that, like, you start getting into real programming projects as quickly as possible, and doing more engineering. And there's a little bit of RL material along the way that's required. 231N is very good because it will have you write your own basic autograd, and that will teach you quite a bit. Back on YouTube. See, I didn't do anything. It literally just like fixed itself. Oh, I missed a couple messages on here. Dario said software engineering will be automated in 12 months. Yeah, he's lying. Yeah. Dario and Altman are just liars. It's that simple. They want money. Tiny torch is a good way. If that's Carpathy's thing, then yeah. Honestly, you can write your own autograd in C. It's not that hard. Like, okay, when I say it's not that hard, like, the thing that's hard is actually just getting the damn derivatives right for comms and a couple of the other ops that are weird. But if you just wanted to write like a couple activation functions in a linear layer, that's a really good exercise, and you can just do that in C. Heck, you can even go do that in CUDA. The code will be almost the same. And you will learn a ton by doing that, and you'll actually produce code that's way, way, way faster than Torch for small models. So it's pretty cool. An N or just anything in some anything serious is fine. If you want to do RL at the same time, building up to more and more complex M's is a great way to do it. You know, but any like reasonable programming projects are good. C is just very nice because doing C is a very good way to guarantee that you don't waste your time, essentially. C just doesn't give you a bunch of bullshit you don't need. Then micrograd. I haven't seen it, Liberty, so. Okay, let's see what we have. So this now takes an env name. Oh, cool. Yeah, so this is actually kind of what we need. Let's see if this still runs. Compilation is very slow. I think we will see if we can do something about the compile times. Okay.so, I see. Oops. Hmm. Well, something did not work here. Let's go look what happened. Dict env quarks. Actually, oh, you know what? I know what's wrong. There we go. Just forgot to rebuild the shared object. 10 milli. Perfect. Okay. So far, so good. There's going to be some jank around different data types to handle. But for now, this is good. Mm-hmm. Ob size 8. Ob size 8, it is 8. Perfect. Yeah. That's what I was checking. Double actions. Cool. So yeah, that's gonna screw with stuff, isn't it? Maybe not. Hmm. There you go. Let me use the restroom real quick. Stomach's a little off. I'll be back. Okay. Whoops. I don't know why I put those on. Incompatible pointer types. Who's supposed to be float? And so I actually think that I'm going to be able to make very good use of this in updating all of the environments because it's very strongly verifiable. Like what I'm basically going to be able to do is take one environment, write a simple test function for it, and then say, okay, do this for all the environments and make sure that they all run correctly. And then we'll be set. Which is nice, you know? I like that. I see. So yeah, this is weird. Yeah, this is weird. Uh, hmm. How should we have this, man? Not everything needs to be specified, right? Not everything needs to be specified. Start from here. Yeah, so like all this stuff, this should not have to be in here, right? Good. Oops. Okay, so 118, where's 118? should be able to delete this. I see the config input size is wrong. Honestly, this is like way nicer. Um, like this, I'm actually very much enjoying the models because I basically get to describe the exact refactoring operation and just have it done faster and not break my train of thought. Though it should be a little faster, you know. The biggest upgrade, frankly, would be if this just happened instantly. If we just had like this instant and faster compile times, we'd be set. What's this? Int. That's fine. And don't let it do dumb stuff. It's way better. Way better. Yeah? Hmm? Oh, that's fine. Let's move some stuff around. No longer hard-coded. So I really enjoy the refactoring process. What I don't enjoy is having to manually type the code and then track all instances of stuff. Though I suppose it is still important to track to some extent the number of instances of stuff because you want the final code to be as simple as possible and have things in as few places as possible. I guess what we'll see is like when I go to look at the final code, I'll see if I've missed anything from doing it this way. That'll be the interesting comparison. I mean, I still think that there would be a use either way. Yeah, it's fine. I'm gonna go grab myself a nice another mug of tea and a few as well once we have this working. This is gone now, right? Oops. Wrong one. Silly. Okay, well, let's give it some additional steps. Because that's like ridiculous. 500k steps. Yeah, that was like a weird config if I recall. It was like a really weird old config. It trains frickin' 16 million steps per second, which is interesting. I'm trying to remember. I think this was like, so this was different architecture. This was the sample efficiency work I was doing. Where's like the old? Is that 20 mil right there? Yeah, 20 mil. Let's try this one. It's probably this, to be honest. Why did it do a templated method? Well, let's see if it's the thing that what. Oh. Yeah, that's growth. It just will try to add complexity for no reason. Eh. No more templates. this. Nice. Let's see if this gives us a proper message at least. It would be funny if it's just this right here. I wouldn't be surprised if it's just that. It should be tolerant to that though. Ten outruns. Funny. Doesn't train the same as before. Not remotely. Try the palm params real quick. I mean the breakout params. Okay, it does learn, and it trains over 10 mil. So we'll have to do, we might have to resweep and stuff, but it does learn. And it trains over 10 mil. It's pretty cool. It's very cool. Damn, that's very cool. And there's our breakout solve. Cool. It's still fine. Make quick commit. Yeah, we need to add these as well. Okay, that's everything. Cool. That's a quick commit done. Um, that's a quick commit done. So I think we bind a few more test environments. So, we make sure that this is working for some different environments. And then we'll see whether we spend more time porting M's or we spend some time on the kernels or what. But, I'd like to have a few more of those environments set up nicely. There's quite a bit left to do. Let me go grab myself a good mug of tea, though. Okay. So there are two environments that I really want to bind. But they're hard environments, and I think we should probably bind at least one simpler environment first. Let's go take a quick look at what I can pick from. Oh, we're just gonna do snake, obvious, right? Yeah, because if we get, yeah, we should just do snake. Discrete space. It's discrete, that's fine. How do you start design puffer system itself? Learn about systems programming. It depends at what level you mean from that, right? So like, what portion of it, right? All of PufferLib is, and that's like all my knowledge. I mean, that's like a million things that I have in my head. If you give me like a specific thing, I can give you a more directed answer. How's it going with Claude Code? The way I'm using it now, I'm very much enjoying it. The way that people suggest me, like tell me that I should be using it, no. Like absolutely not. It's a sign char. Does Torch not have? Torch has int 8, right? How are you using it? I'm basically using it to apply well-defined transformations to existing code. I'm not using it to solve new things. Yeah, this is fine. Something between the CN and the Python C. Oh, yeah, so that's just a combination of relatively simple systems programming. And then, honestly, the best skill I have is being very annoyed by complexity, right? That's mostly what it is. It's just like learning some basics and being very, very annoyed by complexity. You just end up thinking more about how to make things simple than most people do. And that's how Puffer is as simple as it is. I spend a lot of time on it because it really just it's not like I spend a lot of time on it because I think it's the right thing to do for the project. That's part of it, but at a very fundamental level, complexity just annoys me. AI driven. It's not AI driven coding. It's not what I'm doing. Yeah, this is what we want. Okay, double actions floats this. And then snake.c. Oh, okay, it's actually fine from here because the alloc is in here. What? The heck it did alloc? Ah. Aligned alloc, is it? Huh? Tried to smuggle that in. Oh. This is not true. Also not true. Wait, but do the inference of like embedding models. I have to look at what this is. If it's just the embedding layer, then sure. Yeah, I think this is the wrong mindset. It's not as bad as other stuff, but it's still the wrong mindset. Like, I've been very happy using it to apply clearly defined transformations to my code, right? Like anything that looks like, here's an existing thing where it's done over here, do this exact thing but to this other piece of code over here is pretty good. Anytime you give it more freedom than that, it starts making a mess. So I don't think this is going to train yet. See, like the problem with most of these articles of people describing how they're using AI tools is they're not actually using AI tools. The AI tools are using them, and they're doing very, very little on top of it. Okay, this still works, right? All right, so this is now where we're going to start having problems. Continual learning will be solved soon. Well, it has to be freaking defined reasonably to be solved. It's actually kind of wonky if you think about it. The thing that's a little bit weird about the continual learning setup to me, SD, is so some of the really big models, they just do one pass over the data anyways during training. So like you could very easily imagine just adding more data to it and then, oh, okay, it's fine, at least up until a certain amount. Um, it just then becomes an infrastructure challenge. But now the thing that's a little weird is because now you have all this RL in the loop, right? So now there's the question of like, well, if is the new data that you want to inject actually pre-training data or RL data? You can't really go back and do more pre-training once you've done the RL. So I think in some sense, the original continual learning problem is perhaps easier than anticipated, at least for very large models. For small models, I don't know that there is a solution other than just like continuing to train on all the data, like the old data, as you're also training on new data. But I think the significance of it has been massively overstated. I don't think like continual learning necessarily. I don't think that is the thing that's preventing these models from hyperscaling. I don't know if this is SPY's alt or something, Vancouver, but I'm just gonna ban you if you keep doing this. So just stop. I think an external system will be required. Inherited continual. I mean, I think that like RL is a much more interesting case in which to study this in any event. Studying this in language models is probably not the right spot to study it at all. I'm actually very happy with how we're set up, with what Puffer can contribute to the science. Because like we can just run way more experiments faster and cheaper than anybody else. And that's going to be doubly true in Puffer 4. We discussed another. Yeah, whatever. They find like somebody who's gone a little bit wonky. And it's like, oh, but this guy made this. It's like, yeah, whatever. That doesn't mean I'm just gonna blindly believe everything. I did start writing. You all will know though. I did start writing the article with my thoughts on models and Claude Code, but it's gonna take me some like writing sessions to get through it, for sure. Hmm. Okay. Yeah. So here's this is where we have the big issue. Hmm. No, that's hard. We have this typing issue now. Let me think how this should work. So the problem here is that we have different environments have different types for their observations. And this is actually crucial because you want to be able to have shorter types to save the bandwidth. Do I just make it void star? Size. What's this obs type? It's a macro, right? Ads will look like. I think the future of ads is going to just be garbage. It's already garbage. I've seen like this is why I'm very happy. I have for the most part I just don't get ads anywhere because whenever I happen to see any, it's like, wow, I don't want to share a planet with whoever made this garbage. What in the actual hell? Why drinking that much of a coffee when you could get the same caffeine? Would that be more optimized? No. Because this gives me something to sip on, where I actually get some fluids and I don't dehydrate myself throughout the day. And it's also basically impossible for me to have too much caffeine with this. I had like 4 monsters a day when I was an undergrad. That shit is not good for you. You will do permanent health damage. I actually have a much more reasonable amount of caffeine now. The one double shot of espresso won't hurt you. I just don't like it. No, this is just tea. This is just like fairly weak black tea. If I drink coffee, I drink it black. How much water do you drink per day? However much water is in all these teas. It has very little caffeine for the volume, so it's not just dehydrating me when I make it with this amount of water. Favorite white noise? Hey, Nalacha. Nalacha, welcome. Yeah, I've been sick, so I haven't been on. D-type equals float. Okay. We can macro it, we can void star. I think it has to be void star, right? It's black tea with milk. It's black tea with a splash, like it's a very small amount of milk. I think what we have to do here, right? Well, let's see. It's kind of sketchy, honestly. Like, I'll show you the problem. So this thing here, I'm thinking we either have to make this like templated, or we have to do this with some fancy macro over the type, which is gross. Or we have to do, this has to be a void star. Let's actually go through this with. Simple LLM. I got pretty good results. What did you do? My initial Claude code stream was the most depressing shit I've ever done, man. I don't know if you saw the follow-ups. I'm using it in a completely different way from that original stream. What did you do with this simple LLM? I haven't been on Twitter. Twitter's kind of just been cancer lately. So Claude Code just built this. Yeah, dude, Triton is not minimal. What are you doing? Wait, what? Man. Well, at least I'm not criticizing your code by criticizing this crap, because this is Claude. Fucking hate this project structure so much. No, man, yeet this code. This is not simple LLM. This is like big tech prod, like enterprise fizz buzz thing. Okay, this is less bad. This is just like dense torch, whatever. Torch-esque. Not actual torch. It's mimicking torch. It's funny though that like mimicking torch is actually completely like bad, because torch is actually a bad design for hyperf. Stolen from VLLM. It didn't even write its own kernels. Oh, that's hilarious. I mean, I really don't like the like, oh, let's just let Claude think for us thing, or do everything. I've been having way more fun using Claude to just like, people are saying, oh, use it as a tool, but then they'll use it to replace their thinking. I mean, actually use it as a tool. Like, use it to quickly apply well-defined transformations to your code that would take you a long time to type out, and you get a couple syntax things wrong and have to recompile and break your train of thought. Like, that's what I've been using it for lately. And, I mean, the results are we now have 10 million step per second training. So, it's nice. Giving it time. Yeah, I actually thought that you did, because it looks kind of compact. Did you see Hightail? Yeah, it looks awesome, man. I'm really happy that project succeeded. Wanted some practical experience from RL after year's month of Sutton Bardo, Kevin Murphy, and Toy Project. Neural MMO seems fun and challenging. Any general advice on exploring this field? So Neural MMO is the hardest env out there for now that's fast. It's a pretty tough one to start on, though it is just bound to Puffer, so you can use Neural MMO 3. Don't try Neural MMO 2, it is too slow. Neural MMO 3 is 1,000 times faster. Honestly, all of my best advice, man, is on this article right here. Like, if you do this, you will get into the field and it will be dramatically less painful than it would be otherwise. Everything there is free as well. Tried going brain dead? Yeah, man, I don't recommend that. It's awful. I think this is fine, right? But wait, then how when you do the mem copy, I see. Yeah, this is fine. Also add how you use it. Now, yes, I'm going to do that. But I mean, if you just watch what I'm doing here, you will get the sense of it. And I want to be clear, there is no skill, like there's no like learning curve for the LLM or anything like that. Like that wasn't what it was. It's a very simple decision. It's, are you using a tool or is the tool using you? It's really that easy. I think I agree though with this thing here that the best thing is we do just make this void star. We're gonna see where this rabbit hole goes at least. I think that this should be the easiest. We only have to do it in one place. Maybe two if we do actions, but I think one place is easier. And on GPU, it should still be void star. What is this shit? I think it did something weird. Oh, I see. It's kind of gross. Create its own docs, and then every time you see a solution. No, I don't like that, man. That's too high level. I don't like that. That's way too high level. For your UI. I mean, that's fine. With my work, right? Like, what I do with Puffer requires me to simplify and go lower and lower level and make things faster and faster. Going higher and higher level is the opposite of what I need to do. Vibe coding, yeah, so I'm not doing that. And frankly, I think that the reason that you want to vibe code the UI is because the web APIs that you have to use, like the web UI toolkits and stuff, are so garbage. Like, I don't blame you. I wouldn't want to deal with that stuff manually either. But then in what I do, right, like, the goal is to produce things that people do want to deal with. Raylib is a great example of this, right? If you want to try graphics that actually don't suck and that you want to do stuff manually with and like learn things, Raylib is awesome for that. Basically treating cloud code as your intern? No, I would give interns way bigger. I give interns way more stuff than this. Are you kidding me? The guy I will be bringing on as an intern this summer kicks Claude's ass. Intern is like, hey, go make this drone fly with PufferLib. And do it in a way that's like actually good and produces fast, simple code. Claude basically gets treated as better IntelliJ. Next gen, what's this? Oh, cool. Yeah, material science is one of my top top things that I'm interested in for RL. The thing is, like, I'm not really tracking what people are doing now because I can virtually just guarantee you that the stuff that I plan on doing with PufferLib for science is going to be so different from what anybody else is doing anyways that it's virtually irrelevant. This is kind of one of the cool things about going like really, really far off the beaten path is that you can basically guarantee that anything you do is going to be completely novel. I don't like this macro, but it's fine for now. Right now, simulation ML. I don't know. I'm happiest when I just get to do things. It's like a very fine line though, right? Because like there are people that like to do out there things because they like to solve interesting problems, whether or not they actually end up being applicable to anything in the real world, right? And then there are people that like to solve real world problems, whatever the method is, and like, if it's just making something that's a little bit better than what the next guy is doing faster, then they do that. I like to solve things that are like out there that have real world applications but are kind of way off the beaten path. That's what I like doing. So I kind of get to just like work on stuff in peace and not kind of have to participate in the whole zeitgeist. It's much better this way. I guess this is fine for now. I'm gonna have to think of a better way to do this macroing. Log. I think I have one that would be open to that. Peptides, no. Mm-hmm. Depending on how negotiations go in the next couple weeks, honestly, we might be capped. Like we already might have as much business as we can handle for now, depending on how the current negotiations go. I personally already have plenty of client work, and I'm already like, wanting to spend more time on the core. Most likely that just means our prices will go up once I launch Puffer 4. What the heck is this OB 6 that was in there? That shouldn't have been in there in the first place. That's weird. Some old test code. What limit? I don't know what that is. Why small policy, more steps better than large policy, less steps? Yeah, sure. This paper. Go read this. RL needs more samples than supervised learning. There's less signal per step, essentially. Limitless is a movie. I don't watch movies. Oops, one moment. I've been kindly delivered some breakfast. That's nice for a change. What is this? Ugh. Hmm. I don't think there are other options that it'll come up with. Let me think about this and eat some eggs. And of course, it gives me the worst suggestion possible. Hmm. Wait, this one is typed and this one is void, right? Hmm. Let me think about that. Hey, Debris, welcome. Having some breakfast on the side here and thinking about how to fix this, like, weird macro thing. Hmm. Hey, Lance. Oh, right. Yeah, I was looking. I couldn't find the damn. Where the heck it has banned you on YouTube? Is there like a block list? Do you know? I can do that now while I'm eating. I basically, I like fat finger banned him. Oh, I think I see it. Lance. Boom. There you go. You're unbanned. Let me save. There, you should be unbanned. I just fat fingered it. So there's like a right click option in Restream that like blocks, and I fat fingered it when I was trying to like do some other thing. Can we macro the type itself, or is that stupid? So Moon, the latest version of 2048 is pretty good. If you join the Discord, Kyung has been doing a lot of work on that. So 2048 is pretty challenging. Not to get 2048, but to like actually get really high score. It's got this nice log linear curve. Most of the other ones are actually pretty easy. We also have, there's a project Jess has been working on with Spencer. They've been working on self-play for chess, but that's probably more advanced. 10 mil plus, yeah. Well, we wouldn't be able to train the size of the Dota 5 policy in a few hours, right? We'd be able to train that number of steps in a few hours. If you resume the same conversation with it, and you haven't asked it a bunch of stuff in between, its memory is in tokens, not time, right? So its memory is not dependent on time. It's dependent on, like, it's dependent on the text that it currently has in its buffer. For this 4K LSTM, they reduced it. They didn't reduce it to 1K. They increased it from 1K to 4K. It's 168 million parameters, I believe. Just self-play similar to Alpha Zero. It doesn't use search crit. So it's pure on policy. It's pure RL with no search. Let's see if we run into another problem with this. Now we don't need more macros, which is nice. It's just the size of the frickin' D type. So it's a little janky. It's a little janky, but I think this is like... Because otherwise you end up with the Void Star not casting correctly, right? I think because we're doing these as standalone DLLs, it works. What? Now it's being dumb. What the heck does it think it's doing? Wait, what? This type isn't defined. Give you some compute to try to train 168 mil on complex tasks. I don't think there's much use in that though, man, because like we can run hyperparam sweeps. Actually, this is something we're doing with Puffer 4, is we're going to check the scaling. And I don't think it has a favorable data compute trade-off to scale to that size for most problems. I actually suspect that they would have ended up with a much smaller model if their environment were much faster. And also if they'd had some of the more modern architecture tricks as well. Presumably their policy was quite slow and inefficient. What's it complaining about? Oh, you get this from... Oh, get this. If I tell Claude, like, hey, Claude, do A to B, it's pretty good. But if I tell Claude, like, hey, Claude, do A to C, it'll then do, like, A to D to E to G to X to I don't know what failure state, to, to whatever. then back to C somehow. Mm. Debris, we're not using an LSTM in Puffer 4. I actually suspect that this architecture may scale better. So we're going to see in this one. But in Puffer 3, I remember it was not worth going above 512 hidden dim. Write out A, then B, then C. No, what you should do is you should write out A to B, and then you write out B to C. What if yeah, Jess, we're doing, we're refactoring this so that we can have, like, all the different M's working with Puffer 4 now. Hmm. So there is a problem for me to solve here. One moment. I didn't think the min LSTM architecture was as good. They had this weird norm operation on it that I didn't like. Mingru has been good. There was one substantial gate change that I had to make to Mingru, though, to make it work. Because you either need RMS norm or this, like, additional gate change that I made. So it's not exactly Mingru anymore. Just because I hard-coded everything for Breakout for testing. It's a little complicated, actually, because there are much stricter requirements on how we handle the types of all the different buffers now. So I'm figuring out a nice way to do this. Mm-hmm. Mm-hmm. Okay, I see. So this is the problem. This can't get included here. Mm. Hyperball is NGPT. Is just, what do you mean it's just NGPT? It was a small optimizer change, right? See, this is much nicer because this is like, I tried a few things. I use this to apply the changes. It realizes that there's a problem. It suggests bullshit fixes, and then like I get the actual fix. Because this goes into env binding, and I think this works now. How do you discover the adjustments in PPO? So what is it? The sampling thing, the filtering change was inspired by, I guess it's like generalized or adapted from the Gigaflow paper. Um, and then once we were doing filtering, I went and I grabbed prioritized experience replay and just adapted that. So I mean, it was kind of several things that existed, but then substantially adapted and tested extensively. And like what is it? The puffer advantage function was essentially me just applying important sampling. Was it clip sampling or whatever to like the per element computation of advantage, and it turned out to be very similar to retrace, but for on Paul, or mostly on Paul, whatever. What on earth is this? Ah, that's fine. Screwy looking cast, but no biggie. Same thing here. I mean, is this like slightly obnoxious? Yes. I think this is the easiest way to do it. I can't think of an easier way that you would go about this. I guess if you didn't have macros, what would you do? Like the env would just tell you what type it has. You'd set some flag, right? And then depending on the flag, so not a macro, just a constant, then you would conditionally, like every op would be conditional. Incompatible. Assigning to char from float star. Okay. How about breakout? Breakout still works and snake doesn't, which is some weirdness. Fairly minor. See, it was nice to see you back on the timeline. See you around, man. Good luck. He's got you should go check him out, guys, if you're looking for compute. He's got a pretty nice little interface for buying compute at the lowest price from all the different vendors with a nice setup. thing up. Hey, user. That'll do it. And there we go. It's pay more thing. That one lasted a couple streams though, right? Billing. One, two, three, four. 5 credits. Mathematically, both. Hang on. See. Both reduce. Both reduce training to hyperspherical constrained optimization. Numbers are fixed, and learning proceeds entirely through directional updates. So, I don't know if that's a good thing or not, frankly. If that's even how it works. When you say both, oh, see, I don't know NGPT. Muon is quite different, right? Muon is preconditioning. That's quite different. That's not even the right command, my guy. Oh. I guess it did apply that one small fix. Cool. I don't think this works yet, right? Find key. Cool. So this needs to be... Yes. Hey Lalo, welcome. Start these. And now this is probably still not going to work because we don't have multi-agent. So presumably this hangs or does some weird thing. Oh no, it's just ridiculously slow. Heh. Okay. $16 times 256. 4096. 1. Yeah, so this works and is fast, right? And look, it's training. A little bit at least. Even though this is like not at all the setting it's designed for. There. Okay, and it's very fast, yada yada, right? Okay. So now we basically need to get the num agents thing. So thankful I added domain randomization to chess. I suppose that makes sense, Jess. Suppose that makes sense. Let's figure out this thing, and then I'll go and get myself a cup of tea. The way we do this now, we have like num snakes or whatever. It's a little jank, right? I'm back to like 90%, Jess. Okay, so I didn't really think about the... I didn't really think about this from the C creation side. Did I? Well, for now, what we can do is we can add multi-agent. Right, we can just add like, what is it? Yeah, we can add this. Ooh, that's gonna be rough, isn't it? How'd you discover the improvements? I mean, it was like adaptations of existing things that I thought would be promising, plus lots of extensive experimentation, right? Like the Gigaflow paper for the filtering, which didn't work for LSTM, so I had to substantially adapt it. And then prioritized replay made sense to go with a filtering based thing, right? And then the advantage stuff was an adaptation of importance, like clipped importance sampling. And it was specifically added to combat oversampling with prioritized replay. Let's see how this thing is supposed to work. So you make m's of I. Where does m's come from? You allocate your m's. Oh, right here, right? Works. Do we just assume num agents? Where are we gonna get this from? Do we assume every env has num agents? We'll do it this way for now. We just do this incremental, right? Yeah, so this is like the commented thing, right? And just do everything will just be num agents. It's an easy replace. I don't think it actually finished the update. It didn't finish the update, right? Super slow. Back size. Yeah, that's fine. We make that total agents. There's a little refactor to do there. If we can get this thing working though today, this will be nice. Like if we can just get a whole bunch of the M's working, then we can actually start testing stuff. And this is actually here. This needs to be fixed. This is still blocking. Update the indexing. Units per buffer is fine. Let's see what it's doing here. Do I need to change this? Threading. Oh, yeah, that's just redundant. Yeah, that's totally just redundant. That's fine. It's old. How many M's are we making? 16. Oh, it's hard-coded to do way too many M's is the problem. Yeah, it's probably just, it's spawning like a stupid number of environments, I'm sure. That's what we want. I don't think it's an M for parks, though. Oh, no, it is. Mnum M's, Mnum agents. Now if we run this, 16 environments. Okay, but now we're not training, right? So let's try this. Is it environments? Does this actually train though? Like, this should be super easy, right? Yeah, I don't think this is actually, wait, episode return and score. Oh wait, no, score is what we want, right? Score is the snake length. So no, this is actually, this is good. Score is correct here. This actually is training quite well. Yeah, and then this should be training very quickly. It's not though. Presumably, like, the block sizes or something are screwed up. It's probably just the launch arcs being, like, too big of blocks. I'd imagine. Yeah, 256 block size. Oh, well, this would do it. Let's try this. Uh, this. This is fine. Okay, true. This is a little sketchy because this is like an easy place to screw stuff up. Though if it does get screwed up, we have I mean, we'll be able to know immediately. We have very nice tests for this. I mean, ultimately, this is just like changing the tensor shapes a bit. Oh yeah. By the way, people, if you have not started PufferLib on GitHub, please do. It's a great way to support my work for free in about 5 seconds. And we are almost to 5,000 stars, which would be pretty freaking awesome because, like, what are the biggest repositories in RL? Like 9K? This has been around for like many, many, many years. So, you're getting up there. 8 is 4096. How many are missing to reach 5,000? 91. The puffer appreciates your support. Oh, that's doing something. Kind of something, right? Better than before. Let's see if breakup still trends. Okay, this still trends, right? Yeah, it still trends just the same. Well, see, now the thing is we don't know, it's also different policy as well. So that's now annoying, right? Oh, but we have super basic policy. Which is just flat. No. We have one hot. Okay, so we do have the one hot policy. Okay, so I think we have to sort out models next, right? Because like otherwise, yeah, we gotta sort out models next. No big deal. Though actually, I think it's weird because it does like at least mostly work with let me try one other thing. If I do like 256 M's, what's that? And the num agents per N would be what? 4, 16. Switch them maybe. It's quite a bit better. It's very unstable though. Presumably something screwy going on. Presumably. I guess one thing we could do to check would be like 2 and 1. Hey, welcome. Reached nearly alpha 0 on go with pure self-play and off-pol. I don't get how this would be possible. Why would it not be possible? It would be a ton of compute. That's stable. NetEase is legit. NetEase is actually quite legit. 7 GPUs only. What new algorithm though? Huh? Latest against latest. But what the hell is this new, like this algorithm? I don't see anything in it. These are 2080 Ti's? That doesn't make sense. Well, first of all, it's entirely irreproducible because it's like apparently they just like kept doing like they kept screwing with the latest model. Wait, they say they have 2K elo here. I mean, I'm very suspicious. Like soft Q just doesn't work. So yeah, I'm very suspicious, man. You can definitely look for stuff in here, but I'm very suspicious. Episode returns as Q value targets. Huh? Yeah, this is really weird. Appendix. No appendix. I mean, if this result is actually true in any sense, though, it would be very encouraging. CNN back. Everyone does the 18 residual blocks for Go? Yeah, that would absolutely catastrophically nuke speed. They're doing 19 blocks. Hmm. I mean, we could go ablate it, right? I'm pretty suspicious of that for non-pixel ends. Like, one thing we can do for that, Spencer, is just once we have some stable M's for that, we can just do, like, num blocks in the ResNet as a hyperparam and sweep it. Shocked by the claim? Yeah, it's sketchy. That's, like, suspiciously... I don't know about that one. I don't know about that one, man. Hmm. Unstable with 4. Yeah, see, so this totally crashes. And then if I do with this, let's just make sure this one is stable, because if this one's stable and the other one isn't, it'll tell us something. Much more stable so far, right? Yeah, let's go just... I'm gonna let that go for a bit. I'm gonna use the restroom. I'm gonna get a cup of tea. We're gonna fix multi-agent, and then we're gonna port over a couple new environments. I'd really like to get the driving end working, and I'd like to get neural MMO working, and we probably have to do custom policies as well. I'll be right back. Okay. No. Let's go try. Terminals are never set in snake.h. Huh? Do we not do that? So we'll set that after. But I think this is before I was even bothering handling terminals. It's like the first major env. Or first, not even first major env, first fast env in Puffer. I'll start looking for it as well. Sets everything. Okay, so you have num agents gets allocated. Initial looks fine. Per buffer stuff looks fine. I mean, I suppose we could also do screwed it up here maybe. Total agents. I mean, I guess it could also be, and when we create the buffers, create rollouts, horizon segments. What segments? Hyper.segments. Yeah, I'm looking at the same thing as it's looking at here. Where do segments even come from? Get quark segments? I think there is a damn segments. Batch size. I don't know, Turtle, I don't care. It's like this boring ass question. Figure out what the heck is wrong with this. We need multi-agent so we can bind neural MMO and drive env. I'd like to have both neural MMO and the drive env work today. That would be nice. Presumably shouldn't be too difficult. There is the shared init thing that's a little weird, I think, in drive. I must not have updated. There. So no warning. Segments is going to be 4096. The heck could it be? Get this batch, total agents divided by the number of buffers. I suppose, yeah. I wonder if we can tell based on the speed. Would that make sense? The speed should be different. Was this a 6 mil? Wait, 4096. So 6 mil. It's hard to say. You can do that. Yeah. Yeah, once we get this working though, then we'll be able to pretty quickly start getting the other M's ported over. Be very nice. I'm actually really enjoying this work. Like, it's nice to see how all this is coming together. And it's always like the fact that now the refactoring stage is easier to make faster. The problem with refactoring is it takes forever. Like, I actually really like the refactoring process. I hate how like slow and manual it is. Prince. See, batch 2048 buffers is 2. That like looks good to me. I think what else it would be. What else would this be? I think what we can do to figure this out. We could try to port the nets in. We're multi-threading anyways. Looks fine. Okay, we can do this. Fine by me. Let's see what this does. Now I have to watch this to see. Well, hang on. This one, we want to check the apples to apples. Which should be this one. Right, which should be 4 M's. 4 snakes each. And let's see if this is stable or not. We're expecting this to go over 100 and just sit there. If it's correct. Yeah, this exact same behavior as before. It's irritating. Yeah, I think it would be the rollout stuff by now. Would be my guess. Well, it does that. I'm going to think about the models. Yeah, I think it's just going to be we add a basic interface for this, and we add some if statements for now. Total agents. Yeah, I think those match. I don't think that's the critical bug. Okay, I think we have a rough order of things to do. I can see, like, in my head pretty much what everything should look like, I'd say. Pretty much. We still have to handle multi-discrete actions. We have to handle a few other things, but it's pretty good so far. No, it's not this. Yeah, it's floundering. I think we go do the model stuff just in case. We'll just go do the model stuff, and then we'll see if that makes a difference, because we are training this with a really stupid model right now. I guess it could technically have some weird effect with it. I wouldn't think so, though. Like, if I just open up my local real quick and I just do, like, fuck. Yeah, it learns really quick, right? I am seeing 256K. It does have a slightly bigger policy. We should go try to match that stuff. Because it has is it 256? Where the heck does it have this configured? No, it's 128. I guess the OBS encoder is just really freaking big. 11 by 11 by 8, it's like 1,000. 1,000, yeah, that adds 100K params, cool. So it can't find anything wrong as far as I can tell. We'll go do the model stuff, and then that'll give us a very clear check as to where this instability comes from. Because it could technically be something else, right? Yeah, it's sort of floundering and just wasting tokens. That's okay, though. I think what it's going to be then is we're going to have... We just add like encoder and decoder interfaces for this thing. See, yeah, it's wrong. This is an independent thing. It's completely independent. Isn't it going to be worse than one with search? Maybe. It's still a damn good self-play benchmark environment, though. It's actually kind of unclear. Like, if you make the environment fast enough, right? It's a very good benchmark either way. Because, like, you know, you're doing explicit search as part of your algorithm. So how good can you make your algorithms without explicit search? Because without explicit search is substantially more general. Cool. So minimal interface. That's actually kind of fine, right? I think this is kind of fine. It's false. It just copies everything. One hot, two. Oh, that's fine. And then why does it have int64t? No. Oh, because I didn't do it there. This is fine. We'll do that. We'll deal with these int64t bullshit things after. Then default decoder is now a decoder. Get rid of these. This is fine. We'll put... Hello, welcome. To accept an encoder pointer. This is not quite what I want. Oh, actually... no, you don't. I don't want this. Can we do this without templating? Set encoder. Have I don't like this. This is where C++ I think is garbage. Any module. Oh. Is it any module? That's kind of sketchy. This is why I hate C++. It's like designed around, it's designed to be object oriented, which is dumb in the first place, and then it does it in the worst fucking way possible. Register module. I suppose this is fine. It's okay. If we have to fight Torch a little bit for this, it's fine. I mean, I obviously wouldn't do it this way. Okay, gets rid of core, that's fine. Well, that's fine actually. That's fine. It can be a module. Coder, yeah. And then do this, update, get register module, linear, that's fine. What are we doing here? This value function. Why are we deleting the value function? Oh, because we replaced it, duh. That's fine. Register the encoder and the decoder. And presumably we will have some annoyances with Torch on this. Yeah, but that's essentially what I was envisioning. Because now you just pass the encoder and the decoder to this thing. Whoops, this is the wrong term. Lovely. Didn't update the binding. Oh. Creator of G2048M always returns to 0 for terminals on purpose. It's being changed to 0 right after being set to 1 before the function ends. Really? You sure? Ah, yeah, that looks like a bug to me. It should be in here. It should be at the top of step. That's such a common bug as well. Okay, fine, stupid bindings. Not everything needs to be exposed like this. Let's play Flappy Bird. It's literally like my suggested tutorial project. Like, don't expect it to be a super useful end or anything. Puffer will just instantly solve that. But it's literally my suggested tutorial project. All the config was swept based on those bonkers. Okay, so we need to resweep a bunch of stuff. Yeah. This is what happens when I'm like off doing 4.0 things for a while. Things get stale and weird. Presumably, resweep plus term should be better. I mean, this is Puffer 3.0. Why does this say Puffer 3.0? Oh, there's no Puffer 4.0. correct here? Shut up, Claude. Go away. Nobody likes you. Okay, so is that more stable? No, it still screws up. I mean, this is the original config, right? How is this slow? Wait, 2.7 mil? Hmm? Oh no, wait, we have 1.7 mil. Weird. Very weird. We still stable here. Oh, we lost half our speed. Wonder if that's the... buffers. There it is. Can't just do max like that. Which end is this? Snake. 8 gigabytes of RAM enough for sweeping. Yep. With pretty much everything it is. Maybe 1 or 2 M's not. Sweeps aren't done, we don't do parallel jobs on the same GPU. We do like 1 experiment per GPU fast. Okay, there's our speed back. Still stable. No more catastrophic failure. To 4 mil out of the box, not terrible. Now, why is it unstable is the question. Why is this not trained nicely for us? Because if I just do like 8192 snakes, if I just do this, right? I bet this works. Yeah. Yeah, this train's 6 mil. Score is not super fast. That's a little irritating. I mean, in that case, then, like, do I really know what's the problem? It is training. I mean, that is training. I do wonder why it's a little bit slower. Presumably, it's getting hung up in the nth. But that is something. So then, this one. How about the number of actions? Is that a thing? Four. Wait, obs n, act n. Act size. That's weird, right? Act n equal act size. No. How do we know? How do we know the num logits? PufferLib. Is the output size? Policy, input size, num actions, right? Hypers.num actions. Oh. Lol. Is this not... There you go, dummy. I like how it couldn't find them. There you go. So probably it was just learning to move in one direction, which is much easier with one agent. Like it was missing one of its actions. Something like that, I'd imagine. Or it could be memory alignment. Could have been a bunch of things with that, but whatever, we're good. We are good. That should help. That's not a thing. That's funny. Yeah, that's Samsung. Narrowing. Yep, wrong action space. And look, again, it tries to frickin' return Act N. Actually, this one it might be justified in doing this one, right? Okay, this one's actually justified. The other num obs didn't need num actions. Okay, well, you can do that for now, fine, until I think of something else. Much better. That ought to fix Pong from being screwy as well. We'll see if this actually stabilizes it, though. Could be other errors, too. Definitely this one. The heck is this? Oh. Annoying. Search plus RL? What? Why do you think there's not... Oh, I didn't see that. Why do you think there's not much research turning around search plus RL like Alpha Zero style projects? There's the... I think it's Tsinghua or something. There's the whole was it Efficient Zero line of work? The problem is that their code base is absolute garbage, and it's really freaking hard to implement those methods. And also it's like, it only works in very specific classes of environments, no matter how you do the engineering. It's a pretty restricted approach, is the annoying thing, and it always takes a ton of compute. So they're just a whole bunch of things going against it. Do Pong and Breakout both have 3 actions? They do, right? Yeah. So then actually Pong was already correct. We got lucky. Hyper is probably still different. 48. There's 4 actions there. Oop. I don't know if it was bindings or the end, one of the binding files for sure. Oh, literally. You idiot. Look. Don't worry, guys. It's AGI. Forgot to update the frickin' signature. Don't worry. Superhuman programming, by the way. Okay. Segfault. Good job. Probably needs this. Yeah. Started training for a second there. This should train. Some weird slow config, but whatever. Weird config. Breakout still good? And breakout still good. See, it's just super unstable there. If I do this, though, I think it's stable. Workflow. Yeah, exactly, right? That's fine. You still need to have control. And also, it's specific to this exact thing that I'm doing as well, Ice, because, like, you have to sort of keep in mind that this is a very, very messy code base because I've got C environments, I've got CUDA kernels, I've got C++ libtorch, I've got PyBind to the Python trainer. I've got a lot of moving parts, and there's also like their DLL boundaries. There's the CUDA C++ boundary. There are a lot of different things here I'm dealing with. Okay, interestingly, this is actually super unstable right here. The single agent is super unstable. That wasn't true before, right? Single agent training super unstable? Does very well for a little bit. Could just go fix the terminals bug real quick. Oh, where do we want this? Oops. Yeah, step snake. Yo, Unk. Yo, Flex. You better have something to flex if you're calling me Unk. That's more stable. Oh, I spoke too soon. That's annoying. I am curious though, if I just do this, what happens now? No, say this is a mess. We can go try the breakout params just real quick because you never know. Um, you never know, right? Like the breakout params might just fix it. Like we probably do need to resweep a ton of stuff now. What's this like? Ah, see, this is still broken. Let's see how this does. Ridiculous gamma for snake, isn't it? Something is just very unstable here, I think. Well, I suppose we'll just see which M's work and which M's don't. And that will probably let us narrow in. So if I run this, first of all, we probably want 32 M's now. .7, yes. Closer to what we expect. It's just very unstable, yeah. Yep, so we have to do Cleaning things up for 4.0, exactly. Here's what I'm working on. New bindings, stability, profiling, all that. Is there a roadmap for each release? This one is C++ backend, 10 million steps per second, actually quantify where we're spending all our compute, and then Constellation, which is our new like large scale data visualizer. That's Puffer 4. Okay. It's kind of fine. Change anything there. Runs at least. We're gonna have to port the network over. Yeah, okay. So he's got some stuff. Ooh. Alright, I gotta go look at what this thing is. I think I did this mess, actually. Here's my mess to clean up. I'll figure it out, because this one is a very nice benchmark, and it's substantially faster than Neural MMO to use as a benchmark, and it's still quite representative. Here's a restroom and grab some new tea, and I'll be right back. Definitely not end of January, Jess. Maybe not even February. There will be it'll be stable enough in February for you to play with it though. Okay, let's figure out what the heck this thing is doing. So decoder, decode actions. What do we have for this? Oh, it's not that bad, right? It's literally just like your standard. And then what's the hidden size on this thing? 512. Okay, yeah, that's not bad at all. Yeah, literally can port that. That's super simple. Wonder what will help checker self play. I mean, you have the slime volley end, right, Jess? That it's not turn based. You got that one. Yep, this is the exact way that I have this. Why? Oh, this is fine. Yeah, it's not using our fused kernel though. Yeah, this is bad because it's not using our fused kernel. Well, we can just say, let's just have them be fused. 2 layers. Generalizable trends among self-play versus non-self-play. Not sure, Jess. Ted Funky. Yeah, this is the problem with having everything being a little off, right? Like you either need the M's to be known good or the policy, like the RL and model to be known good. It's very difficult when everything's a little off. Yeah, this is fine. Oop. That's good. This updates. This is fine, yep. Spencer's testing good baseline AI. Maya's trained most human move. Which I see. Yeah, he was telling me about that. I mean, that sounds like everything is going according to plan. The research is hard, Jess. This is why I do so much engineering. Like whenever I can reduce, um, whenever I can reduce problems into engineering, it's much better. It's a lot more consistent. Yeah, it's much slower, which is expected, right? Now, the thing that's a little tricky is, yeah, this is like way slower, which is a problem. Looks promising. I'm gonna test it later. Yep. Really? Missing? Wait, what? Why is this shit in here? Yeah, no wonder this shit does not need to be here. Go away. There we go. Okay, so this says 1.7 mil for G2048. 3.7 mil params. Interesting. With an LSTM. And Vecna MEMS is... Oh, this is 16K EMS as well, though. Okay, so 1.7 mil with 16K EMS, right? Okay, we definitely should not be slower. We should be much faster. It's at least more reasonable. So 1 hour test is annoying. Do you think a reasonable hidden size? I would believe that you see improvement at 256. I would believe that you might see improvement at 512. It would be interesting if it goes higher than that. Typically, our fancy M's cap out around 512. To include? Yeah, you can include, like, in the sweeps or whatever, yeah, if you don't know OM it. For sure. to bind more of these M's, don't we? Target's a really nice one to bind, right? Target continuous actions. No, it's multi-discrete. That's a pain, though. Handling multi-discrete. What else do we have that's not multi-discrete? We have neural MMO, but like... Connect 4 is supposed to work pretty quick. I'm going to use that as a quick check. Triple try it as well. Alright, connect 4. Let's see how this goes. This one doesn't need a custom net, right? No, doesn't need a custom net. What? It's like, squirrel! Is the obs type a float? Yes, it is. That's fine. A good environment. Opus goes, ah, squirrel. Okay, I guess it decides to do cat or whatever the hell. What? I thought it already did this. Yeah, it did. Thing. Alright, that's nice. This is the Python version. Oh, I forgot that the Connect 4 env is like stupid slow. It's a very easy env though. Yeah, it's a very easy env. This is why we don't use this, man, because the AI for this, like the opponent AI is so stupidly slow. Like 10 mil, it's already 0.95. Push some PRs, speed up some kernels. Wait, what kernels did you speed up? Hang on, let me go check in a second here. Okay, so this is broken. Lovely. Let's go look what this is. Let me go grab the... What kernels? Oh, this? Wait. Wait, we aren't using the RMS forward backward. What? Hang on. The original kernels didn't work for this. Wait, I'm confused. Okay, since these are a huge number of changes, I've got to ask, are you a kernel dev or is this like 100% vibed? I'll check it either way, but it's going to tell me something very different. Because those are the kernels that we need to be faster. But like a couple of the ones that you've edited, like we didn't have the numerics checks even passing for yet. Like the PPO loss kernel would be nice. The biggest one's the fuse scan. I do like writing kernels. Okay. Let me check. So this is the most important one right here. This fuse scan op is very, very important to us. sort of check. Wait, reduces. What? Fuda? Wait, I'm confused. Huh? Constantly saving. It uses checkpointing. How does that make any sense? Wait, what? Explain to me how you checkpoint this. Wait, if T%. I'm so confused. Did you run the numerics checks on this? I recompute. Did you run the numerics checks on this? Because we do have tests to show the that this is numerically correct. The two things that we want to see, right, are that the training is still stable and that the numerics checks pass. Chunk storage. Chunk start to chunk end. Computes the data it needs. Wait, hang on. So A star, S buff. Recompute and store. So wait, why is that better? I'm so confused. Trading memory for some recomp, but there's no like buff cur is equal to, wait, buff cur. This is a slow operation though. The recompute operation is like, this is supposed to be a pretty slow op. Like, I'm not sure. What does checkpointing get you? Because this is still chunk end minus equals checkpoint. Oh, okay, so wait. But you're still doing the entire sequence. I'm very confused. Jonah, have you run the numerics checks on this thing? I'll be dramatically more interested as soon as I know that the numeric checks pass and that, like, at least Breakout still trains correctly. Because, like, for instance, I didn't mess with any of the fast math intrinsics at all because I was worried about that. This would be a very significant contribution if this is still correct. Right here. And which other ones do you have? So you have... This one would be nice, but the thing is the PPO kernel is like, this is not numerically stable yet. And then the RMS forward and backward is currently not used. I'm not sure if you looked at the code. Though if you made it this much faster, we might actually be able to use it. So RMS norm is basically, we're not using it right now because it's slow. If you have a fast version of it, it might actually be very useful. Intermediate data that's used. All the chunking says we don't need to much because we can just recompute. Yeah, but I timed those ops and I didn't think that those operations were fast. I guess, yeah, it's possible that the memory bandwidth is worth it. Like, it's worth it for memory bandwidth. But, like, when I timed those ops, like, it seemed like it was actually pretty compute heavy. So let me show you where the test is. Because, again, like, if you have this thing still like training stable, I'll be very, very interested immediately. So we have this, where is it? Scripts. No, where is it? Profile. So we've got this profile kernel script here, right? You can also run setup.py build profiler in order to build the profiling script. And then we've got this profile kernel CU. This does speed test, so this is nice for speed test. I think one of them has correctness checks in it. I have not ported all of the correctness checks, but we still do have right here in test microbench. So this thing has correctness checks right here. Like where's an example? Like, yeah, okay, so here's test fuse scan, right? There's your inputs, and then it does test kernels, and it will give you the numerical diff between the Torch version and our version. So the two things we need to know, right, it's like, it's got to be numerically about the same or better as before, or at least it's got to have stable training. And the most important kernel is that fused scan kernel. Mingru is also like, Mingru is important, but Mingru is mostly just pure memory. Like that op is pretty fast as far as I can tell. The fuse scan op is the one where I think that a lot can be done, but it's kind of hard. What GPU to target? I've been running my tests on a 5090. 4090 is fine. Any of the consumer cards like that are probably good. It shouldn't matter that much, though, I wouldn't imagine, because, like, these are all element-wise kernels. We're not actually using the tensor cores at all. We're not even element-wise. This one is seq-wise parallel, but, like, still. And I will say, so, because I don't want to discourage you here, if you actually are able to make the kernels faster and keep them numerically correct, that is a major contribution. And it's very likely that if you have some experience, you'll be able to do that. I'm a new kernel dev. But the numerics are important. Like, otherwise you destabilize training. So if you get back to me with those and say, oh, this is actually correct, then I will immediately, like, merge it into a branch. I'll test it out on stream. We'll see if it's stable. And I'll probably have a few more test M's stable, so we'll be able to really, like, make sure it's good. Tomorrow this weekend? Awesome. I will be streaming all day on Saturday. So, if that is helpful, I'll be around. It's a little unstable, right? Right here, this like feels a little bit unstable. If I do this. Okay, so there's some kernel jank, right? Yeah, look at that. Can I put CUDA graphs back on at least? Yeah, so we can see we actually still have some screwy numerics here because it works. It works without the custom kernels. Yeah, that's good. So we're not using this one. I thought the other one should be stable. It is actually kernel numerics, though, it seems. Oh. Wait, now it works? I'm confused. Is it just intermittent? Oh, okay, I see. There's just a tiny bit of numerical jank somewhere. Yeah, because that's working. Cool. So that is connect 4, 24 seconds. Nice. Let's go fix Pong. You know, I want to like figure out what's wrong with Pong actually. So okay, so yeah, we have a lot of things wrong with Pong. Num_ems go to 4096 like this. There's a mill. And then I believe it was supposed to be, let's go try this thing. We can try also with and without the kernels on. Okay, so that didn't do anything, right? And this doesn't optimize at all. That's interesting. Right? That doesn't optimize at all. Probably have like the wrong number of M's or something weird. Try this. I think the original Pong should work. see. Now this is 700k FPS for some reason. This is 2 million or 20 million? 20 million, so why is it that bad? That's very weird. Well, we don't have we don't have this max mini batch size thing like this anymore. Let's real quick. Let's just take out kernels as remove some new numerical jank. Oh yeah, but those kernels are really needed. Otherwise, what? How is it that's friggin' slow? Nothing. Okay, so the params are jank. $400k steps per second. Lovely. I don't know how on earth it's even that slow. It doesn't even solve. This is like the easiest task ever as well. We'll puffer 3 params. Okay, this is what I was remembering, right? So this is 12 mil steps. So this, we want this to solve, right? This should solve. And then, what is it? Num updates or something? Num mini batches that we need to provide. So let's see, Python VMs. This is 4092, or no, 4096. Right, 6 times. Horizon 64. 8 mini batches, I believe, is correct. Okay. And then hidden size. Hidden size is not altered, so it would be 120. Oops, no, 128, like this, right? There. That's way better, right? There's your 4-second solve back. I don't know what the heck we were doing with those other params. I think that was from like weird constellation stuff. So that's a 4-second solve. Okay, and that's a 2-second solve. Way better. Let's see that again. Don't blink, you'll miss it. Doop, doop, doop. Done. 10 mil step per second. Though I think that it needs the post eval. Either that or it needs to be retuned a little because it doesn't solve every time. That's 21 right there. But that's pretty nice. Yeah, that's pretty good. So a little bit of numerical jank, maybe, but pretty good. Pretty good overall. So, what's up with Snake? You know what's up with Snake? Cell size. Initial state, really. That's annoying. Because the thing is, this is like a whole custom ass annoying policy, right? If I just do this, can I still learn some shit? So this should be 16 M's. Big. Yeah. It does not like this. Let's make sure we can actually solve this, you know? Default gives you your LSTM. This. It's 8 times that. Okay. That's good. This. There we go. Hey, Bet, I'm mostly better. I'm back up to, I don't know, I'm back up to like 90%, I'd say. This garbage. Alright, so there's our basic snake net thing. Interestingly enough, this one doesn't train either. So something weird happened there. Hmm. And you muted. I'm back up to like 90%, man. Yeah. Yeah. Okay, so this is not training. Um, Interesting. The fact that they're both not training. Oh, you know what I bet happened here? I bet we broke all the M's. Yeah, we broke all the M's. I'm being stupid, I'm sure. Yeah, exactly. Action tensor being passed. Yeah, exactly. Well, that's what's going on at the very least. We'll go make sure that our config is reasonable, I'd say. Let's go do that first. Nothing yet, but it's there's some work. Goal, have several M's bound and working, and some refactoring as well. This is the same config, yes? I don't see no mini batches in here though, that's a problem. Yep, so this is not updated for Puffer 4. Let me see if I can compute that real quick. So it should be 4096 M's times 64 horizon. 2, 7, 6, 8. Okay. Okay, so that's one of them. $4096 M's. It's like just super unstable. Let me just make sure. Turn our kernels off for a second. No, it's not just our kernels, you see. There's some numerical jank either way, it seems. It's not just the kernels. What was our policy size? Policy name was Snake. But I'm pretty sure that it was like a really stupid policy, right? I'm pretty sure it's not changed. Mm, well, it's multi-agent and like semi-competitive, so yeah, but you can still get some good results out of it, and it's still a nice test end. Okay, and this didn't change. I want to just make sure that this is actually the multi-agent jank, because, we might have just, it might just be the env. Let's take kernels off. And then we're gonna just do 4096Ms. See if this is stable. Okay. I mean, this is still janky, right? So I don't think it's the env necessarily. I think it's our binding still, but it's not just the multi-agent. So let's not waste time then on that. There are like a number of things that could cause that, right? Let's go find another env to do. I'd like something else that's multi-agent with but the thing is we need a single discrete action space as multi-agent. Drone env maybe, right? No, wait, drone's continuous, right? Yeah, continuous. Alright, we don't have that. Do we have anything that's multi-agent with single discrete action spaces that we know we can train quickly? MOBA? No, I think MOBA is multi-discrete. Go as single agent without self-play. Hardware? Or trash pickup maybe? This will do it right here, Rware. It's got float obs as well. RL be used to play poker. Yeah, sure. I'm gonna go get myself one last cup of tea. We'll bind Rware, and then I want to get the more complex M's in today. We shall see. I'll be right back. Okay. Hey, that guy. How's it going? Is that it? The binding file. I think it's just that. For the purposes. I mean, if you look back at what I'm doing with it, this is I'm describing a precise transformation of the existing code that's essentially applying a template based on other things I've already done, right? So like watch the actual modifications. Change from int and unsigned char to double and float star. Okay, replace all occurrences of that as needed. Look who's adopted LMs. Yeah, just not remotely in the way that idiots were telling me to. And it also depends on the project as well. Like for this, I have CUDA. I have the CUDA to C++ barrier. I've got the C environments. I've got the C to C++ via DLL barrier. I've got the libtorch C++. I've got PyBind to Python. So, and then I've got tests on top of these. So pretty much any individual change requires updating in like 8 places. So that's the main issue with that. You'll get a lot better value from Claude Pro. I thought that their limits were shit, man. I'm just porting various M's over that guy for testing because we're testing 1.4.0. That's fine. It's fine. Bunch of casts. Not that many casts. That's fine. Okay, so this is literally the exact code from the other file pasted in here, and then all it had to do was go template match this new thing at the top. Right? Fix for terminals. I want to actually wait. Did you train it or did I thought we had to resweep? You said it doesn't train, right? You do resweep. Yeah, but like pushing something that breaks training on an env without pushing the sweep is not helpful. Right? Because then what's gonna happen is I'm gonna forget that we have to resweep, and or it's gonna turn out there was something else weird, right? So what I'd want is I'd want that PR with the new hypers and like the new train curve, where it's like at least as good as the old one. What in the hell? My God, what are you doing? Like literally can't even handle the stupidest basic task sometimes. With height map choice. Don't worry, guys. Definitely AGI. Choice. Super Maven. Fucking thing. Stupid. Bots, get out of my way. Okay, good. That's what we wanted. Failed to find key. Vec.h. With oh. There. Hey, look at that. And it hangs. The original do that? Freaking hangs. I seem to remember there being some weird thing with that, though. Yeah, this one hangs as well. Alright, so, we match. We match perf. Stupid thing hangs. Apparently. How do we not catch that? Oh man. Lots of cycle weird things. Any thoughts on LSTM handling history versus stacking? LSTM should handle history. It's possible there's some jank thing where it works better stacked, but you're gonna screw everything up in the process, including bandwidth. Apparently Rware hangs, which is fun. I mean, we have this now working. Like, this is a matched curve, though, at least, so it works as well as it does in Puffer 3. Speaking of which, I just did it on 2 machines, 2 different versions, and yeah, annoying. Yeah, now we'll be able to save Puffer 4. Hangs in the middle. There. It's hanging. See? Annoying. Okay. That does mean that we have multi-agent working, though. So now what do we do? Multi-discrete sampling. I'm gonna do the neural MMO bind. Diagnose the hang. I'm not going into Rware specifics right now. Actually, this thing still has context, right? Room for improvement over CNNs. Similar head of replacing. Um, CNNs are really slow on the encoder side, I've noticed, yeah. Somebody would have to benchmark it, though. Like, what you'd want to do is you'd have to compare, you basically have to compare flop efficiency of small comms to small linear layers or small mingru layers and see which is worse. mess up my nice neural MMO code, you shitty bot. Is it 1707? Double. Good. Good. That's fine. 20. Presumably I've done this. It's 4. Can I not just do this? Just do this myself. Did it add that? I didn't think it did. Yeah, this stupid thing forgot to add that completely. Okay. Agents, now we have this. This is num agents. Go like this. Oh, this is fine. I'm gonna type like this. Does it run? Nope. Why do some of the top AI conferences have such high acceptance rate? Less than 5%? That's not how this shit works, dude. If conferences had a 5% acceptance rate, um, the vast majority of PhD students would fail their PhDs, and you'd probably just not have people doing PhDs. And also, the funny thing is, like, the selectivity is basically just a lie, anyways, at these conferences. Because the review process is pretty much just noise at the moment. There's almost no signal in it. And also, selectivity applied to research just makes no fucking sense at all. Like, you should publish anything that is, anything that is like, anything that is like demonstrably conducted well. If you like can show something and you actually have done the experiments well, it's up to the research community to determine whether it is useful or not. Deciding like, oh, this shouldn't be published because I don't think it's useful enough is not a good mindset for research. The problem with selectivity is people publishing stuff that is just like poorly done and their conclusions are invalid. Not like, oh, we're publishing too many papers, so we need to be more selective. Fuck bet? That's a comment. That's the cabal. Yeah, conferences are a mess. Alright, why does this thing not work at the moment? Probably because, yeah, we need to do some. Why the fuck would I want to live in China? I mean, to be fair, it's not like I think our cities are better. Our cities suck as well. But at least we have nice suburbs. I mean, I just don't want to live in a city, period. Like, why? It's not exactly fair to say China doesn't innovate, but the education system definitely suppresses it a lot more than the US system does. I mean, they have way more people though. Like they're gonna figure it out, and some of them are gonna figure things out in spite of the system. I don't think that the education system, for the most part, was particularly helpful to me. You know, I think I learned most of the stuff I learned in spite of it, or maybe to spite it. You know. There we go. Let's just do. I don't think you just can use min like this. So awesome. I have no idea what the fuck this is in the chat. Bet we got far better stuff to worry about than this though. Um okay, there we go. So yeah, that's 1.5 mil with a stupid architecture though, right? Yeah, with very stupid architecture. Do we have policy? We do have the policy hidden size set here. So actually, if I set to 120, is it faster? Oh yeah, it's faster. That's 3 million. We can actually train neural MMO nice and fast if we want. Okay. So now what do we do with that? Well, we need the freaking encoder is the problem. So it's just the LSTM, and then what we have encode. Decode is nothing, right? Yeah, decode is nothing. It's proj. Proj is also nothing. Cool. So this needs to be exactly. I mean, it's a pretty nice, simple little operation. Torch can 100% port this, right? I mean, Flood can 100% port this. Just doubled SPS. Yeah, because I cut the network size down. I was trying to see if we were full end bottlenecked or not. It seems we're not. So presumably we'll actually be able to have reasonably fast neural MMO. Though I mean, I'm suspecting that all the time is getting lost in this big stupid encoder here. Time is this 4:18. I got another hour and a half. I don't need this decoder, do I? Oh, I do need the decoder, damn it. That's fine. Yep, we'll do that. Is there a way to speed it up? We're gonna see. At least, dude, we have like way better profiling tools than we had before. X payouts went up. I don't know. I haven't been posting a lot of stuff, dude. I've kind of been staying off of X. It's been really gross lately. I have a couple articles I want to release, but I've been writing one of them on language model stuff, but I think for the most part, I'm kind of just chilling and deving Puffer 4. Everything else is sort of just noise. I saw I got like 80 bucks or something for having barely posted anything this month. I don't know. Best article. And whatever. Weird that it's done this. Expected int 32 and 64 for index. Okay. C plus, oh, it's in scatter. Map from 2. I think this takes long index actually. We'll see. Huh. Well, I mean, if that's real, that's still a decent speed up. 750. That's something. Presumably now we can also, like, we have the tools to make this way faster, because we lost half of the speed on this conv encoder, right? That's cool, though. That is cool. So I have to support multi-discrete as the thing before I can do, I have to support multi-discrete before I can do the drive environment, which I want to get done. Maybe we will figure out multi-discrete today. Like, the reason it's annoying, right, is... Let me find it. Actually, how the hell do I do this right now? This weird frickin' sequence pad thing, right? Okay. Yeah, that's a bit annoying. We have this soft-maxed. We have this sample logic kernel one here. Ooh, though, I guess since we have a kernel, hang on. We might be able to, like, actually just have a good kernel to do this stupid sample op, right? That would be cool. A multi-discrete sample kernel. I think we need one to do it, annoyingly. I'm gonna have it port the, while the context is fresh. I think that one has, like, way more substantial shared in it and bullshit, though. We'll see. I'm not letting Claude write the kernels. Are you shitting me? This is good. There is an SM1 support. Heh. They shipped Spark without. Wait, 12.1? Shouldn't be. I thought it's 130, isn't it? How fast is the Spark supposed to be? That one, it actually might have needed the cast, to be fair. I'm not positive. Didn't put the shared function. Oh, it just went ahead and did the encoder, that's fine. It missed this, though. That's fine, whatever, that doesn't make a big difference. Yes, it's this one. That's how it's set up. Right now, we just have elif, elif, elif on all the ends. We'll come up with something better. There's quite a bit of custom logic in there, isn't there? Yeah, this is sketchy. Yeah, it makes a new env, which is not gonna work. It's kind of complicated. That's obnoxious. We can at least start on the multi-sampling, though. Miles, 120 gigs of RAM. Okay. I'll be right back. Use the restroom, and we'll see if we can get multi-discrete sampling. Alright. Hmm. Yeah, so the big issue now, right, is just gonna be, multi-discrete sampling. Multi-discrete sampling should be like way faster now though, right? Yeah. Way faster. Just needed a custom kernel. I'm trying to think if I want to do the custom kernel right now. It's like kind of awkward. Actually, I'm pretty sure I can get Claude to do it if I describe it exactly, because it's literally, hang on. The sampling op itself is forward pass only. It's essentially adding a for loop, right? It's literally just adding one for loop. Well, actually the harder thing is figuring out how we pass in. We can do this in multiple stages, actually. Yeah, we can do this in multiple stages. Noma actions, right? Nice neck. Oh yeah, bet I hit so my birthday was last week and I got before I got sick, I ran a 20-minute flat 3 miles, so 6:40 pace. That was the other bit of exercise I've been working on lately. No wonder you got sick. Nah, actually, they kind of gave me some other weird stuff to do, and they had some stuff that probably put some strain on my immune system. I've been going to the public gym, so like, no, I'm gonna try something a little bit more chill tomorrow. I'll probably do like a 7:30 pace tomorrow for 3 miles. I think I can I think I can manage that, no problem. And disappear. Yeah. I'm trying to fix my shoulder as well. I've been getting some I've got like some PT and some like injury assessment stuff and stretches to do. They basically told me, look, your shoulder's healed. You just have really bad tendonitis. Yeah. Mm-hmm. How the hell do we make this thing? Like, how do we handle multiple actions here is what I want to know. You basically just need a list to loop over, right? I think it just is gonna end up being like int star and int star length, like int star like counts and then length or something. Okay, that's fine. It's good. It's all static, so you can actually just do this. act size for allocation. That doesn't make sense. Gonna loop over, and that's gonna get us the output shape. Yep, so that's fine. Yep, num actions for allocation. Start times. But what's num actions 2? Yeah, that's fine. That's what we want. Yep, this also makes sense. This needs to be updated to num actions like so. That's fine. Updating existing binding files is fine. I actually don't even know if you need the num. I think we can probably just do size of. We'll try that after. We'll do this first. Super simple refactors. Drive also will need it. Decoder needs act n for output, yep. Make tuple. Sum of sizes for output. Yes, it does. It's going to need both. I'll let it do that for now. The main thing is sample logits. Annoyed that it's renamed num actions. That's fine. Okay. Yes, the main limitation here. Yeah. The thing is, like, I'm happy having this do it because in my head, I know pretty much exactly what this should look like. Um, so this is very strongly verifiable by me sitting here. Because I know pretty much exactly what this should look like. It needs to just return both of these things, the length and the array. And then the kernel, see, because it's no longer a tensor op, right? Before we had to do this padding bullshit. But now because we just have a kernel, it's just an extra loop. And it's not a bad loop either. So this should be substantially more efficient. Okay. So let's see, first of all, we're going to go look at this and make sure it doesn't mess this up. It's an important kernel. Yes. This is correct. Okay, and then it doesn't need to pass num actions because it gets it from this stride here. This is fine. That's actually better. Why the fuck is it messing with my RNG? Huh? Wait, 1560. Almost. Hang on. Okay. So it moved this. It should not have moved this. I actually don't think it matters that it moved this, but, you know, whatever. Did it move it outside a loop? No. Okay, that doesn't matter then. Find max for numerical stability. It removed the clamp. I don't think it did. Look, it moved it. It's just hard to read the diff, dude. So look, it copied this code directly under to here, right? And then here you see the logit offset. It has the isnan here. It has the exact same clamp from before. Okay, it just, look, this is now it's going to be this code followed by this code. So it's exactly what I said, right? It's this extra loop. Num actions, and then you loop up to this to find the max. And then this stays inside. Okay, everything goes inside this loop now. Log sum x for softmax denominator, which is right here. You know what I'm going to do? I'm just going to copy this function here. So I'm going to keep a copy of this because we're going to test. We're going to test this after. Multinomial sampling via inverse CDF. What? Wait, hang on. What did it just do? Oh no, that's our exact code, right? Yeah, no, this is already our exact code. Fine. It just adds this offset. Now breaks the inner loop. And then log prob of sampled action. It's just moved this down here. Yeah, and then this is very small mem bandwidth. Cool. Now you're gonna see, right? Like, look at this. This code, this is what we have now. You're gonna see it's gonna be the same code, but no loop. Same code, no loop, right? So I kind of showed you, right, that like it was just gonna be a pretty simple transformation of the existing code. But like as you can see, a ton of stuff needs to now be updated because now we have the launch function. And then we have the stupid wrappers. Here, you know, we have these stupid wrappers, right? And now we have more stupid wrappers. They're in two different places because they have to be. Because CUDA to C++ boundary. I guess technically they could have made the... They maybe could have made it so that the syntax was compatible. It's kind of tough to know, actually. I kind of see why they have it the way they do, honestly. The NVIDIA stuff's pretty solid. Oh, look, more launch function bullshit, right? It's 4 different places that you need to update this, by the way, just for the headers. So this is the 4th one. I think that's it. I think it's 4. This is now updating the module signature, because there's a torch module for this as well. And then there's going to be the call from C++. So now you see why I'm using Claude for this crap, right? You see how much redundancy there is? Like, Claude would be nowhere near as helpful if I had just like a pure CUDA code base, for instance, and I just had this one place to update stuff. It would be way easier doing this type of thing manually. Right, but basically what I'm using it for is just applying all these like very well described transformations to existing code, where you can pretty much tell exactly what the outcome is going to be. Right? I'm not telling like go solve this problem for me. I'm saying, well, the problem is going to be solved by this transformation, followed by this transformation, followed by this transformation, but each of those requires updating 10 different things. I don't want to do that manually. Here, update those 10 things. And I just describe each of the transformations. And occasionally prevent it from doing stupid shit. Wants to add a tensor for act sizes, that's fine. That needs to stay on CUDA. Do you check its worth carefully? Have you not been watching me doing just that? Yeah, and now it's going to return an additional act size. We need this to be one element tensor. No, because it'll get graphed anyways, right? And it's not changing, it's static. That's fine. It can just be a tensor. I'm pretty confident that this will be, like, not terribly broken, because it's a very simple modification, actually. I thought this was going to be way worse. It's kind of funny, because I thought of how terrible this op was in Torch, but actually, when you just have a kernel for it, it's way easier. Yep, and then it's just wrapped from blob, that's fine. And that gets added. Action sizes. See, the only thing that I didn't predict that I would have realized once I'd gone to make the change is that you don't need to pass the sizes and the length because the tensor already has the length information, right? Because you can get it from the stride of the tensor. That's the one thing I would have missed initially, but then I would have gotten that as soon as I started implementing it anyways. Someone want a job on assembly backends? Or get a good score. Same as for real assembly. You went in Hong Kong. Man, what's he doing in Hong Kong? That's funny. San Diego is a very nice place for an office. Like either like Palo Alto and San Diego are very nice. Oh yeah, yeah. Not SF. I like Palo Alto is nice because it's close enough to SF that you can get there easily without having to take a quick flight. So I guess I mean you take a 40-minute flight, you're in SF, so it's not terrible either way. But planes kind of suck. Huh? What the hell's it confused over? Oh, now it's doing silly things. I think that was just a bad grep. Okay, yeah, they're fixed it. Tensor shapes. They already are. They already are 2D. We already did that. Didn't we do that already? Oh, the buffer ones are different. Yep, that's right. The buffer ones are, in fact, different. Is this how I do that? This is how I do this, right? Yeah. Yeah, this is how I do this. You just add one dimension. Yep, that's fine. At worst, this will just add a 1 for things that are single discrete. See, this is like my favorite use for it, is just propagating relatively simple changes like this. Sizes, no action hats. Yeah, so the environment has to give you act n, act sizes. Let's create environments return. Backend star. But see, this is the int and tensor. Act n, act sizes tensor. And act y sizes. Right? $500. Why the fuck do I get a 500 error? Credits. Doesn't say I'm out of credits. That'd be really surprisingly quick as well. Come on, load. Oh, I'm in the wrong browser. Hang on. Oops. What's going on with this thing? I'm not dropping frames. They have an outage or something? Everything is super laggy in there. Yeah, they have an outage. It looks like something is broken with their stuff. Yeah, I still have yeah, it's just an outage. Okay. Size is tensor. So what we can do is we can just return the act size as tensor. Just do it manually. Size. One, right? Yeah, it's the first dimension of act sizes. And then what? Yeah. Right, so this now needs num actions. Where did we make the environments? Yeah, we did. Let Claude diagnose and fix. They have a fucking outage, dude. What do you want me to do? Lo and behold, I can still write code myself if need be here. Even if it's shitty C++ debugging. Conversion. Alright, so now we have create graph. This probably changed. Okay, yeah, before policy, it needs the number of actions. You see, it's just like much more annoying and slow because like it's shitty C++ that hooks in libtorch. The compile time, it takes 15 seconds to compile. I'm going to make way more syntax errors than normal because it's shitty C++. Like, how important it is to have these tools is a function of how shitty the whole setup is. Num ATNSS. What in the hell? What are we doing? Num ATNS. I don't know why this needs to be like this. Sizes. Is this thing done yet? Because like, this is its stupid refactor that it has the stupid context for. Nope, still broken. Thanks, Claude. I get to fix your bullshit. Worthless crap. Act sizes. Let's get dinner. I have a reservation for later, dude. I'm not going now. Okay, this builds at least. Dorsia? The hell is that? Oh, some stupidly fancy. I'm really not into, I'm really not into that, man. I mostly just like good casual places. Oh. Yeah. I don't know. Fine dining goes into the same, like, bullshit status game treadmill, in my mind as, like, Gucci bags and other dumb shit. Pretty much wherever I am, I find, like, a few, like, I find a couple, like, really casual places with good food and a couple, like, somewhat nicer places that have good food. And then that's pretty much all I do. It's not even that it's a waste of money, dude. Like, it wouldn't even be, like, it wouldn't even be like, it would still be dumb to me if that weren't remotely a thing, right? I mean, like, I go to the diner a lot, dude. There's a diner around here where the check for two pretty damn like solid 12-ounce New York strips is under $50. It's kind of fun not being in frickin' California and wherever. Yeah. You could tell me where the dang thing is. Alright, let's try with the torch traces. the city. Oh yeah. Oh yeah. What? That's not what I just... What? Why did this not paste? Oh. What? Dude. Piss off. Come on. There. Okay. Got copy CUDA kernel. '76. Yes. Cool. From blob. Huh? Num actions. Okay. Big storm sitting whole southern US. See you around. So much better. Mm-hmm. Wait, how is this? Now it's seg faults. Oh, because this sizes thing is wrong? Oh, well, of course it's wrong, because I break out. Okay, still seg faults. Interesting. So this act size is definitely supposed to have 2 elements. Visibility. Yeah. So it's this, right? Oh, it's just not getting freaking used. It's like not getting used, I imagine. Is this stupid thing back yet? Um, yeah, it's back. I think this stupid thing is like screwed up here. There's probably some weird DLL thing going on. Like right here. Possibly. Wait. And am I being dumb? Let's export like this. Act size. Let's see if this does anything. Okay, so we have num actions is 2, but then act size is somehow we cannot print. That's very odd. Well, let it fix the names here. Yeah, already simplified. Why is it doing that? Sizes. Oh, yes, that is correct, because then that needs to be moved to later in the policy. That needs to go right before we create the policy. And it only needs the tensor before that. Sizes. Oh, okay, I see. Uh-huh. Okay. It's fine. I don't think that needs to go on CUDA just yet then. Act N, it gets replaced, that's fine. It's pretty good as well. Action heads. I've got 25 minutes to get this into a working state. And I think we can do that. If we can get target working, that'd be super nice, because that's multi-agent, multi-discrete. So that would pretty much mean we have the machinery for everything except this fancy shared M's and continuous actions. 8-hour streams. I'm back to like 90% probably. I've been live 8.5 hours. Draft up. Action select. 1. Oh, I see what it's gonna do. Yeah, that's annoying. Wait, actions dot. No, I don't think that's correct. Sample logits. View batch -1. Hmm? Okay. You don't loop over paths. Uh, Presumably this exists, right? I mean, I don't see how this wouldn't be a kernel. So presumably it's bound to C++. Oh yeah, I forgot we have this bullshit logis to probs thing as well. Oh no, that's a torch function, isn't it? Okay, so mentioned being sick. Heh. I mean, I had a couple of good workouts right before. The head dimension. I think the head dimension should already be there in this case. Act sizes. Wait, what? Why the hell is it like this, dude? Split logits. Oh, I see. Is there not like a dot chunk or something? It's odd. One moment. Well, that's really annoying, isn't it? Assisting on a larger code base. It's actually more useful on the large code base. Um, precisely because there's a lot of unavoidable bullshit going on here. It's actually less useful on my smaller code base, believe it or not. Like, the reason that this is useful now is that there are like 3 different versions of things that are just getting ported to APIs in different languages. There are there's like 7-fold redundancy on headers and things because there are 3 different languages here plus tests. And a lot of the operations are just like pretty simple transformations of the code that just have a lot of redundancy, and I think I can reduce some of that, but there's still going to end up being like a fair bit of redundancy around. It's going to at least be, my promise to you all will be that this the source code here will be dramatically easier to follow than the torch source, and faster. That I can guarantee you. I'm going to get it as good as I can. And also I'm going to expose like big chunks of it to Python. What? Hmm. Split. Well, I think we already handled the one at the end for value, right? I haven't checked. I think it's already handled. Log props. Okay, it's already returned like this, then we're fine. Okay, this is fine. This is a transpose over each, right? I think this is the same as our code now, right? Yeah, the transpose is fine. That matches our code. There is one for loop. That's fine. Pad sequence. And then multinomial. It doesn't need... Shouldn't need this multinomial. Don't you have... See, this is like the limit of what it can do. You see how much it's struggling here? It keeps proposing stupid shit like, ah, yeah, I got it this time. Oh. Oh, yeah, okay. So there it is. Wait. No, it's multinomial. Yes. Yes, it does need multi-discrete support if we don't use the kernel. Exactly. Okay, so now it knows to forward call first with action equals none. Okay, and then what we do, the action equals none path. That's fine, this shit is getting graphed anyways. That's such a mess though, holy crap. Honestly, it's better to model them separately, isn't it? I think this would be better. Yeah. So now we have this thing. And now we can check these separately, which is good. I'm going to take this one as done. I don't like this chunk of code though. It's such a mess. I mean, this kind of like the fact that it gets this complicated kind of just tells you that the torch version's a mess. Multi-discrete action is not none. Okay, graph. Okay, just put it here. And then I put this one here. So I don't know about this multi-discrete path working or not yet. We'll be able to test this. If we can just in the next few minutes have a working version of this that still trains breakout, that would be nice so I can make a commit. I got a whole bunch of stuff done today. But yeah, this stuff just, hey, this is just like black hole for time. This update's just a ton of work. I mean, even with Claude going through and like applying these changes, there's just stupid amounts of stuff in this. This. All right. Do we compile? Okay, good. It wasn't that much to ask for, and we get it. We have breakout still running. So we can make a nice commit and be in a clean spot for today. That's good. I always add everything manually, so I force myself to actually make sure I know what the hell I'm committing. You know, it's very easy to mess up committing all. .cu, .h. That's a lot of stuff, actually, now I'm looking at it. Oh, we also have all the env updates, right? So the next stream will most likely be either tomorrow night or Saturday. I'm gonna be live all day Saturday. So probably I'm gonna rest a little tomorrow night and you know, be ready to do the all day Saturday stream. Yes, this one should have changed. Oops. One moment. I'll do outro in a second. And we'll make sure we have everything. So, because you guys can play with this if you want. It's like getting to be more stable. Still needs a ton of work, but I mean, this is like way better. Um, okay, there you go. 9-hour stream. I am pretty happy with that. Man. For folks who've been watching, I'm back Saturday, maybe tomorrow night. If you're interested in my stuff, I stream all my dev, at least all the public dev. I also have some client work I do off stream. If you want to help me out for absolutely free, feed this puffer a star on GitHub. We're almost to 5,000. If you want to get involved with development, most of it is less absolutely insane than what I'm doing now. Like, you can just do low-level game dev and learn RL in the process and contribute to science and research, and start learning some of the stuff I'm doing as well in the process. All these M's, well, most of these M's are by contributors here. You can also follow me on X for more RL content, including some articles that I'm working on you can't find anywhere else. All my educational materials are there as well. I'm going